Everyone, Alicia Panzarella here, taking a look at an innovation for the modern world. And what I mean here is an innovation for our vehicles that always seem to break down at the most inopportune times. So taking a look at my brainstorming session, I kind of started with where do I struggle, where do others struggles, and how can they come together. So I struggle a lot because I am 5 foot tall, but most of my struggles can really just be mitigated with a ladder. So that wasn't really helpful. But one thing I kept thinking about was strength. I'm pretty strong, but I can't move like an oven by myself. Looking at where others struggle, kind of the same thing came to mind. Strength, accessibility, and something that could happen in an emergency situation, or if you are in a solo situation. Hopefully, it's not an emergency situation where you are solo, but if that would happen, some of the things that somebody could experience would be a fire, a flash flood. I know that I personally was in the flash flood last year in Mannheim, and it was horrifying. Somebody could also experience, an accident while falling and vehicle issues. So kind of taking all of these things together, it brought me to, what can I envision a product for, and most of it came with vehicles. And there are a lot of things with vehicles that you have to be like surprisingly strong for. And one of those things is changing a tire, and another would be breaking the glass in your the window, which some people are strong enough for, but unfortunately, some people are also not strong enough. So those were kind of the two things that I started to think about dealing with vehicles. That would be, emergency situations dealing with strength. So the end problem is how can someone gain enough torque needed for an over-torqued tire when changing a tire is the only option? So I don't know about you, but I hike a lot, and most of the places that I hike have absolutely no cell phone service. And it's not like you don't have cell phone service for a mile or two. It's like 10 miles where you don't have any service. So if you get a tire in those 10 miles, you kind of have one of two options. You either have to start walking, maybe somebody will help you, or really you got to change the tire yourself. Now, knowing this, how can an item not only be helpful for changing something that's over torqued, but how can it be used in more than just one emergency situation? So the end product that I kind of developed was a tire iron that has extending pieces, so interlocking pieces for added torque. And then it will also contain a spring-loaded propelling device to break windows if needed. So some statistics on flat tires that I was pretty surprised by, about 27% of all roadside emergencies are tire related. In the United States alone, approximately 7 tire punctures occur every second, which equates to a very high number per year of 22 million flat tires. So the likelihood of you experiencing a flat tire is very high. And unfortunately, the likelihood of this being an emergency situation is also fairly high as well, especially if you frequently travel and drive through areas with limited cell phone service. There are also some statistics at the bottom for you to take a look at if you'd like. So looking at what's on the market now, I did have a couple personal contacts as I started to research, what is out there, because I obviously didn't want to create a product that was already on the market. So I talked to people at AutoZone, and I also talked to a lead maintenance technician for over 30 years. That's my dad. He has worked with pretty much every tool imaginable because he has to fix pretty much anything imaginable. So those two contacts were really helpful in figuring out that you do have telescoping wrenches, but they really only go to about 21 inches and the maximum is 23 inches. So this one that I found, the Gorilla Power Wrench, this came highly acclaimed from one of the motor sites that I was looking at. And then this was just the one that I found on Amazon that had the longest lever arm. So my thought was that, okay, so I know that this is on the market. How can I create something that any single person who is driving their vehicle could use? So my thought was someone 60 to 70 years old would be kind of the upper limit of changing a tire. But I spoke with the trainer at a local gym to see, about what strength level would somebody between 60 and 70 years old be at. And she did tell me that you're only looking at between 7 and 15 pounds. So here presented a problem because although I was going to create a device that was going to give a larger lever arm than was on the market, even if they were able to produce enough torque, it wouldn't solve the problem of actually changing the tire, because tires are very, very heavy. They're well above 30 pounds. So even if somebody was able to get the lug nuts off, they wouldn't actually be able to change the tire. So I kind of had to abandon that upper limit idea, and I just went with the average strength person. But that doesn't mean that this device couldn't be helpful for somebody in that upper limit. It's just not going to be helpful to actually change the tire. Okay, so why aren't those devices on the market good enough right now? So the average torque for a tire is about 108 Newton meters. So that's between like 80 and 90 foot-pounds. The problem is with these new impact guns, it's very, very easy to over torque a lug nut to about 600 pounds, which equates to about 813 Newton meters. So we're seeing that it's very likely and very possible that a lug nut could be almost 8 times over torqued. So if we look at the average person, the applied force using just arms is about 110 newtons. Using a whole body to push down is about 225 newtons. But if we're looking at the upper limit, because if you're in an emergency situation where you have to change this tire, you're going to be using your upper limit of strength. So push down limit is about 290, and then pull down is about 540. So I took the average between those two and have an applied force of about 415 newtons. So if we look at the largest telescoping wrench, that's about 0.58 meters. That means that the average torque that somebody could apply is about 130.5 Newton meters, which is clearly enough if your vehicle is torqued correctly. But it falls way short if it's not torqued correctly. So using the upper limit, you're going to need about a radius or a lever arm that's almost 2 meters in length. So my goal is to create an interlocking device that will give somebody in the upper limits that 2 meters. Now, if you're wondering where I got some of my numbers from, it's a pretty simple torque equation of tau is equal to R times F times sine theta, but the sine theta is going to be a 90-degree angle because that's going to give you your optimal torque. So we are looking kind of at that optimal stage if we're looking at the upper limit. Now, I will tell you that I did test this theory about 2 years ago. I did have this exact situation happen. My tires were well over torqued, and luckily I was at my father's house and he was able to help me change the tire, but he had to get a barbell from a bench, so very long, and it was about 1.5 meters for the lever arm that he needed in order to take off these lug nuts. So he is an above average strength individual, so it kind of makes sense that he wouldn't need that total 2 meters, but it does go to show that this device will work. But the problem is not everybody just has a barbell sitting around when you're driving your vehicle through the hills of Lancaster County, so you need something that is kind of small, compact, that you can keep in your car. So part one, you're just going to have your standard lug wrench. And I'm sorry, my sketches aren't perfect, but you kind of get the gist. You're going to have your standard lug wrench. The radius is going to be 0.0127 meters. The length is going to be 0.3048 meters, which in the English system is really just 1 inch by 1 foot. Now you will have a removable end because everybody has different size lug nuts, so you want to be able to change that if needed. On the inside, you're going to have the interlocking grooves so that you can attach the next piece to your lever arm to make it longer, which will have those outer grooves. So it's a pretty simple device. It's really just metal tubes that will attach to each other. But it will be significantly helpful in that emergency situation. One thing to note is that I do have handles on the end, so it will have grips on the end so that you can get, like, obviously a really good grip in order to change the tire. or I'm sorry, to take off the lug nut. Also, if it's raining, it would be really easy for your hand to just slip off that steel, so you would want that grip there. So cost and materials. The metal that we're going to use is chrome vanadium steel alloy. That's pretty standard for the lug wrenches. And I will tell you that to find the raw material is a little difficult. You have to, at least because I'm not a manufacturer, you have to go to kind of like a bidding site. And the cheapest that I found was 1 ton of the chrome vanadium steel rods that would obviously have to be melted down. They're about $3,000. So based off of current model weight and everything, it's going to be about a total of 9 pounds for this device. Now, that's 9 pounds when everything is attached, but the base portion is 2 pounds, and then it's 1 pound for each interlocking piece, which means that for a total of 9 pounds, it's only going to cost about $13.50 for the steel per specific item. Now, for the gripping pads, I also found a heavy-duty liner that I thought would be good to cut and put as the grip. They're only going to cost about 25 cents if we use the dimensions of 12 centimeters by 8 centimeters for the end of the tube. So that's only going to add another $2 to the device. There we go. So part 2, the very last piece. So like I said, there are going to be 7 interlocking pieces that are about that 1 foot that will create the 2 meters that you need. The very last piece, which most likely will not need to be used unless these are very over torqued and you have someone of lower strength. The very last piece is probably not going to be used. So that last piece is going to be a propelling device that can break a window if needed. So one thing to note is that the window is made out of tempered glass. So we can see something that is not tempered kind of shatters into shards that are very, very dangerous, whereas a tempered glass kind of just like spiders out and forms millions of little teeny tiny pieces of glass. You need about 24,000 PSI to break tempered glass. So if we have a small ball bearing surface area of about 0.00196 meters squared, then the force that you're going to need in order to break that glass is 323,400 newtons, which you may be thinking, wow, that is a really big number. It's actually not, if you have a very small surface area that you're breaking the glass with. So something like a screwdriver would very easily break the glass. But we're looking at, especially for this part, kind of the upper limit of somebody who has very low strength and is in this emergency situation. So how are we going to put this into action? So we're going to have a lever action will pull back a steel ball. This is also going to be made out of chrome vanadium alloy, and it's going to be pulled back a distance of 0.15 meters, meaning that we need a spring coefficient, so it is going to be spring loaded, of about 2.156 times 10 to the 6 Newton over meters. And do note that I use the equation F is equal to K times X. This is Hooke's law that is specific to springs. And over here, I just use pressure is equal to force over area to solve for those values. Now, you may be thinking, again, this number seems really high. Doing a little bit of research, it's actually not too high. Pretty much any metal can produce this coefficient of friction, and if you go to my 5th resource, you will see that. So the device for breaking the glass, you have the glass breaking device here. You have a finger lever that will pull back the glass breaking device. This will be the slot for the actuator. So once it is pulled back, we see that there is a safety stopper here that will be pulled all the way back where it will be hooked. So it will be in a safe position. So it will be pulled back. This will hook. And then once you're ready, you can put this device next to the window. You can then hit this button right here. That button will release the spring, release all of that potential energy from the spring, and then the glass breaking device will spring outward and it will break the window. Now do note that this is still the last piece of the device, so we still have the grip and everything at the end. So having these pieces will add about 75 cents and then $1 for the spring to have a total price of about $17.50 for this whole device. So not too expensive, and it will get you out of any emergency